everybody, my name is Tommy and today I'm going to be your science teacher. Today is our next topic. Do you know what it is? Well, it is electricity. So, do you know what is electricity? Electricity is something that you might call as just something that zigzags in the air in thunderstorms, right? Actually, that's not just the only part of electricity. So let's learn about more electrical appliances and also how electric things work and how do we keep safe. 1. Does water conduct electricity? First, we're going to talk about pure water, which is water that is not conducting electricity. Our body has about 65% of water. All that water is not pure. The water from our cup or from the tap is not pure, but it is water with mixed salts and other types of good and bad germs. Distilled water is pure water. Distilled water is water that is put in a pot and boiled into steam. Then we will close the pot, we will close the lid of the pot and let the steam turn back into liquid water. We will open the pot and we have distilled or pure water. Now, distilled water can be called pure water, but pure water is not always distilled water. Let's move back to the question. Does water conduct electricity? Well, as I said, pure water or distilled water that does not have any mixed salt doesn't conduct electricity. And water, for example, distilled water that is mixed in with eating salts will be turned into impure water or water that is not pure. That water will connect the two circuits and the electricity will flow through the water to the other end and the light or any other electrical appliance will suddenly light up. Let's move on to conductors and insulators. So, what are conductors and what are insulators? Here I have an insulator. This is an insulator. Insulators include plastic, wood, leather, paper. Actually, paper is wood. So those are the four main materials that usually insulate electricity. What about conduct? Well, conductors could be chairs, actually like metal chairs and types of metals that you have heard of. For example, copper, silver, not gold, not diamonds. We have aluminum, but aluminum is a very low conductor since it's very, very thin, and electricity has to go through a lot of bumps and obstacles to move through the aluminum wire. So that's why when you open up the wires in your house, you always see that they are brown or even green. Those are copper wires. Now, have you ever seen an electric pole before? The pole that connects very long electrical wires. Well, it has about thousands of V's. What is a V, by the way? A V is a volt. And if you know volts, then you could test some things with volts. Remember, us children need to use 1.5 to 3 volts, not more volts. Something such as a hair dryer or a drill use 110 in some poor countries, and in other rich countries they will use about 200 volts in every of that electrical appliance. Okay, now let's move on. Changing the number of components inside an electrical appliance. So, like I've said in the experiment that I told you to test, it has only one battery, one 1.5 volt battery or one 3 volt battery. So now test yourself because now we're going to use a 6 volt battery or a 3 volt battery. Since we have two components, then it mixes up and turns into a battery. Okay, so here's an example. An example is a car. A car has 2 batteries. This is the first battery. It looks like this. It's kind of large. There we go. And then there's another battery sticking right next to it with the same part. This is called a battery. But if we detach these two, they will become a component. So this, for example, is an electrical car battery. Another example is the battery of some electric boards. Sometimes they have a slot at the bottom, and when you open the slot, a few circular metal things fall out, right? Well, those are the components of a 3 or 4 componented battery. That's another example. So, you see, when we summarize all of this, we will end with this: how to be safe when using electrical appliances. How? First, if your house has a carpet, please do not put any wires under the carpet. This is because when people walk on the carpet, then the plastic, which is an insulator outside, will slowly decompose or disappear and only leave the remaining copper part. If these copper parts touch each other, then suddenly it will cause a fire or an electric shock. This moves us with the next one: electric shocks. What may cause electric shocks? First, like I said, putting wires under the carpet. Second of all, never pull out a plug when you hold the line. Never pull a plug like this, okay? Hold the biggest part of the wire so you could pull out the plug. Never touch the wire and pull it out. This will also make the plastic part melt or maybe decompose or disappear away, and will only leave the copper part. And like I said, when the copper parts touch each other, then it will cause a fire, electric shock, or even exploding. Now, this is the one last most important thing when you're using electrical appliances. When you are charging the battery, please do not use the phone while you're charging, even if it's just a battery, a big round or maybe square piece that you will plug it in, or even on the plugging mouth on the wall. When you do that, do not use the electrical appliance. Or, like in some pictures they have shown on the internet, it will cause a fire or explosions that could damage your furniture and loved ones. Okay, So it is the end of today's lesson about electricity. And see you next time with the next video in the fourth grade book